Good day everyone, today we're going to present our project, the CS Undergraduate Academic Planner and Manager. This project is presented by Yang, Saeed, Nori, and Rinzo. Our project focuses on a comprehensive web-based academic planning system. It's specifically designed for computer science students at USM. This system aims to address crucial challenges in academic courses management. It provides an intelligent, user-friendly platform that helps with the effective course planning, progress tracking, and academic guidance throughout a student's undergraduate journey. The purpose of our project is designed primarily we focus on demonstrating the depth of the white box testing in terms of statement, branch, and path coverage, as well as defect location and repair process. Additionally, we supplement this with markup compression or black box testing results. This approach ensures a thorough evaluation of our system's functionality and reliability. Our system consists of several key modules. Firstly, the administrative module, which is responsible for aspects like user management, course management, role and permission management, and advisor assignment. The recommendation module provides intelligent course suggestion, workload optimization, graduation pathway tracking, and academic recovery planning. The planning model offers services such as the interactive course planning, academic progress visualization, grade management, and pre-request validation. And the advisor module includes student planning review, planning approval for student communication, and academic monitoring. Let's go into more detail about the functions of each module. The administrative module acts as the backbone of our system, handling all the administrative tasks necessary for smooth operation. It ensures that users are properly managed, courses are organized, and the roles and permissions are correctly assigned. The recommendation module uses the algorithm and data analysis to offer personalized course suggestions to students. It also helps to optimize their workload and track their progress towards graduation. The planning model is the crucial link between the student and academic guidance. It involves interactive courses planning, give the student a clear view of their academic progress, manage grades, and validate requests. The advisor module focuses on the approval process of the student plannings, like communication with the students and monitor their academic performance.
So now I will share our approach for the test and the strategy. This system helps the computer science students at USM plan their studies. Our goals was to make sure it works well. And first, we need to use two main testing ways. Black box testing, we checked how the system acts from a user view, and without add the code. For example, we test if students can access admin pages they shouldn't, and after a small fix, it should be read in Word. And second, for the white box testing, we looked at the code inside to check our parts. We covered 100% of the code steps, like how the system limits provision 1 to the student to the 12 units. And the next, we will talk about for the details. We test on the Windows 11 with Brave browsers. The database had 200 users and 19 courses. We used tools like PHP unit for the backend and Wisted for the front end. And we ran 44 black box tests with 43 passed, and all 35 white box tests passed covering every part of the code. The system responds quality around 180 ms, and the database checks took less than 50 minutes. There's the room to improve, so that we should make sure the activity students they will can't take too many units, not just warn them. And we need to test it on the phones. Overall, so the system works well and it helps students, admins, and advisors plan studies smoothly. So that's our approach for the testing.
So firstly, I'll be going through the user role management test coverage, where this function basically checks the permissions for each user and decides whether they have access rights to specific pages. If so, it will be redirecting them to those pages. If not, it will be preventing them from accessing those pages with a 403 forbidden error. So we can see the pseudocode on the right side here and the corresponding control flow graph on the left. And I'll be going through each input and its corresponding path respectively. So if the input is a null user accessing a protected route, it will be going from 1 to 3, and then 4 basically returning a 403 forbidden error if the user is null, and then to 15 basically ending this function. So for the second input, if the admin user is accessing /admin/users, which is an authorized route for the admin to access, it will be going through path 2, which is 1, 2, 3, and then 6, and then 7, where the user does have the permission, and then 8, allow the user to access the route, and then 9, 10, and then 15. So lastly, if the input is a student user accessing /admin/users, which is a forbidden route for students to access because it's an admin route, so it's going to be going through path 3, which is 1, 2, 3, and then 6, then 7, then 12, because the user does not have that permission. It's going to be logging unauthorized access and then returning a 403 error and then ending it basically. So now for the user role management test output. So after running the test here, we can see that for students, students are correctly denied access if they're trying to access an authorized route, and admins are correctly granted access if they're trying to access an admin route. A null user is correctly redirected to the login page, and all the test cases are passing correctly. Okay, now for the user registration test coverage. For the first input, if it's a valid AOSM email with a strong password and valid major, the first path will be going from 1, 2, 3, 6, 7, 10, 11, 14, 15, 16, 20, 21, 25, 26, 30, 31, 32, 33, until 37, basically redirecting with a success message. For the second input, if it's a non-USM email domain, it will be taking the second path, which is 1, 2, 3, 4, 37, which is basically returning a domain validation error. For the third input, if it's a weak password, it will be taking the third path, 1, 2, 3, 6, 7, 8, 37, with 8 being a return password error. And the fourth path will be related to the invalid major selection, which is 1, 2, 3, 6, 7, 10, 11, 12, 37, where 12 being a return major validation error. And for the fifth path, it will be a database failure error, going from 1, 2, 3, 6, 7, 10, 11, 14, 15, 34, 35, 36, with 36 being a return system error. And the same thing goes for the user creation failure and the student detail creation failure. Taking different paths, but similarly to the failure. Now for the user registration test output, we can see that all the test cases have passed. Firstly, for the valid registration has completed successfully, and for the non-USM email is correctly rejected, and for the weak password is also correctly rejected. For the invalid major is also correctly rejected, And finally, for the missing international status is also correctly rejected with all test cases passing. Now for workload optimization test coverage, for the first input, probation 1, the path will be going, first path, 1, 2, 3, 4, 5, 10, which is basically returning 12 units maximum. And for the second path is basically probation 2, going from 1, 2, 3, 6, 7, 10, basically returning 10 units as a maximum. And for the third input, which is an active academic status, for going through the third path, which is 1, 2, 3, 8, 9, 10, which is basically returning a maximum of 25 units. Now for the workload optimization test output, for the probation 1, it correctly returns 12 units. For probation 2, correctly returns 10 units. For the active status, correctly returning 25 units. And for an undefined status, it also correctly returns defaults the 25 units, with all test cases passing successfully.
Hi everyone, my name is Mohammed Abdurrahman Nouri and I will be wrapping up our presentation by sharing the main takeaways from our testing phase and final evaluation of the system. First of all, we ran a total of 44 tests to validate the system's core functionality, which included semester planning, course limits, and advisor approvals. Out of these, only 43 passed successfully, which gave us the test success rate of 97.7%. One of the highlights was that role-based access control worked correctly. How so? Each user, whether they're an admin, advisor, or student, could only access the functionalities that are assigned to their specific role. The only issue that we found was with the unit overload features. Students received a warning when they exceeded their allowed units, but the system did not prevent them from proceeding. That's been flagged for future improvements. We used Laravel's PHP unit for back-end testing and read tests to validate the logic paths, and it helped us get a solid test coverage. Overall, one key lesson we learned is that edge cases, especially around constraints such as course limits, require a stricter handling even if the logic seemed fine in typical scenarios. Now, in conclusion, our testing phase has shown that our system is both functionally sound and logically stable. All major modules, ranging from academic planning to advisor workflows, performed reliably under test conditions, including both common and edge cases. With a strong pass rate and a clearly defined test coverage, the system is now considered ready for deployment, which means that it can be deployed anytime now as all the major functionalities work as originally planned and the testing shows that. Aside from a few minor improvements, like enforcing hard limits for course overload, the platform is stable and we are confident in its ability to support real academic scenarios moving forward. Thank you, everybody, for listening to us and to our presentation.